Hello and welcome to the training video for circuit cubes and robotics. My name is Siobhan Pawelczyk and I am the stream coordinator for the Diocese of Buffalo. I'm excited to share this academy with you. I actually am the author of this academy and had a lot of fun researching it and developing it last summer. I really hope you enjoy this training video and I hope to see you soon. Thank you. So the first thing I'm going to ask you to open is your Stream Academy binder, Circuit Cubes and Robotics. I developed this academy to really sort of complete the learning for our students prior to coding and robotics. We saw that there was a gap there between learning about circuitry and then all of a sudden we are coding and driving robots around. But there was no correlation between building circuits and then building robots that are driven by circuits very often. And then we lead the students on towards coding and more difficult robotics. So that was the reason for developing this academy. While I was doing a lot of research for this academy, I tested out various different things. I looked at squishy circuits, great product, uses Play-Doh to complete circuitry. And I also researched this product as well, Electro Dough Kit, which is also a really, really nice product. It's got great components, very inexpensive. You can even buy the components, make your own Play-Doh, lots of different things you can do with those. But I ended up choosing to work with circuit cubes because I really like the durability of circuit cubes. And I also really, really enjoyed the way that they connected together with Legos. So that's the history behind why I chose to work with circuit cubes. If you go to the Circuit Cubes website, you will find out that Circuit Cubes was developed by some teachers for the purposes of teaching elementary school children about circuit cubes. So it's been very, very well developed. So inside your binder, you will see the title page with circuit cubes and robotics. Then you will see a page about Elevate Education with Stream Academy, a bit of information about why we teach using the Stream principles. And then we talk about why engineering and why this is very important in the 21st century classroom to encourage our kids to work with their hands and engineer. So it's a really important article. And then key strategies in facilitating the engineering design process. And lastly, an introductory letter from me about circuit cubes and robotics. And then I need to talk to you about the shopping supply list. So the shopping supply list for this academy is really, really simple. You can go to the Circuit Cubes webpage, tanakalabs.com, and purchase a classroom kit, a Circuit Cubes classroom kit. And in this classroom kit, you will get 10 separate classroom kits. So if you have a class of 20 students, they get a kit, one between two, and it comes with all the components you'll need to complete everything in this academy. The other items on the shopping list are copper tape. You can buy this on Amazon. You can get multiple rolls in a pack. It's very inexpensive, and it's adhesive. The other thing that we need for the first session is button cell batteries. And yet another thing that we need is LED bulbs. And we use these to learn about the circuitry right at the beginning of the academy. And we also need general classroom supplies such as scissors, tape, paper clips, felt, tissue paper, scrap paper, things like that. So for your teacher prep, I would encourage you to go to circuitcubes.com/pages/educate and download the lesson plan book. I would also encourage you to gather lots of Lego to supplement the parts in the kit. Always ensure the battery packs are fully charged in the Circuit Cubes kit before you start using them in session 3. And check out the Circuit Cubes YouTube channel and follow Circuit Cubes on Twitter for some fun videos of things that people have built. I can actually tell you that at the Extreme Games last December, I was so encouraged to see the wonderful things these students had built that had had this Stream Academy last fall, I was really blown. I was actually brought to tears because I really saw my vision for this academy actually brought to life by the students. So it was very, very encouraging. So I really hope you let the kids flow with this academy once we get into the nitty-gritty of circuit cubes. So the next page, page 9 in your binder, is the table of contents. And each page is numbered, and you can flip to the sessions that you require. This binder is going to be available in electronic format on your USB stick along with this training video. I will also include on your USB stick the Circuit Cubes lesson plan book, a copy of that as well on the USB stick, and a PowerPoint presentation which accompanies this academy, which I will highlight to you at the end of this video. So let's take a further look at the binder. Size of that, there we go. Session 1. Each of the sessions run in a very, very similar way. Session 1 begins with objectives. So the objectives for session 1 are to learn about the history of electricity and where does electricity come from. I would prep for this class, open your PowerPoint presentation, inflate 5 or 6 balloons and gather some scrap paper. Very, very easy. And this session is really an overview and to find out where the students are at in their understanding of electricity. So for the first few minutes of this session, I would invite you to talk to the students and find out what they know. Where does electricity come from? How long have we had electricity for? What do you think life was like before we had electricity? And what type of items use electricity? So open the discussion with those questions. When the PowerPoint presentation is open to session 1, there are links to the following videos. Electricity, History of Science. This is quite a long video. It's over 12 minutes long. And it's quite involved for 3rd through 5th graders. But I think it really gives our students a really good understanding of how far we've travelled in our journey with electricity. While I was researching, or while I was gathering my thoughts together to put this training video together, I also found another video which I have posted on the PowerPoint presentation, which is a much shorter video and gives a shorter look at the time length of, or timeline of, electricity. It's developed in Australia. It's quite a funny little video and I think maybe quite catchy for the kids. And then we also have 2 more videos that are quite short. The Story of Electricity, a basic introduction for kids, and The Story of Electricity, another separate video. So feel free to show one of those and have a discussion. Feel free to show a couple of those and further the discussion. They each highlight different things, but when you prepare for this academy, you can watch those and determine which ones fit your class the best. So once the children have watched a couple of those videos, I always feel that videos can highlight the ideas that we're trying to get across in a much more succinct way than we possibly can in the classroom. And the kids are very, very engrossed in anything on a screen, as we all know. So the students are very engrossed in anything on a screen, as we all know. As we all know. So I would encourage you to show the videos to really get the history of electricity and the story of electricity across to the students. So now I would say to repeat the discussion that you first had and see what answers they have picked up from the videos they've watched about where does electricity come from and how long we have used electricity. The activity for the session 1 is quite a short activity. It's really probably something the students have done before, but maybe don't know the science behind. So we would pass out the inflated balloons and scrap paper and ask the students to rip the scrap paper into small, small pieces and then rub the inflated balloon on a sweater or their hair and use the balloon then to pick up the small pieces of paper. You can explain when doing this activity that opposites attract and that the negative charge on the balloon is attracted to the positive charge of the paper, and that's the science behind it. They know that magnets opposites attract, north and south, so this should be an easy concept for them to grasp. You You can also try and stick the balloon to the wall and do other fun static electricity experiments if you have time. So to complete session 1, introduce the students to the fact that you'll be investigating circuits for the duration of the academy. Next week, you will explore paper circuits and make some of their own paper circuits. And then further into the academy, we'll explore a little bit more about robotics and the importance of circuits in robotics. And finally, we will use circuit cubes to make simple robots. So the homework for next week for the students is to have an idea of a design that you would like to see on a special occasion card that could use a circuit and lights on it. For example, a Mother's Day card, a Christmas card. You could also invite the art teacher to help you with this. Maybe after you've tried this a couple of times on paper, to make a card in art would really be a great crossover, and really using those stream principles to do project-based learning when we can. So getting the art teacher involved in a paper circuits card that lights up is a really great way to show the students how they can use these techniques they learn in many different subjects. Session 2, the objectives for session 2 are to learn about circuits and explore paper circuits. Preparation again is to open your PowerPoint presentation to session 2, print a paper circuits template, and gather the paper circuit supplies: the copper tape, the batteries, and the LED light bulbs. So first, project a simple circuit onto the board and point out the components that make up a simple circuit. Maybe ask the students to try and point out the different items of the simple circuit. Here we have a battery, wires, and a load, which happens to be a light bulb. The electricity flows in a continual loop from the battery to the light bulb, which converts the electrical energy into light and heat energy. But don't tell the students that just yet. We want them to come up with that on their own. So part of the discussion questions can be that you've all used batteries at home, and do your batteries stay full of energy, or do you need to recharge them or place new ones in your device? And then ask them, why does the energy drain from batteries? Where did the energy go? And these are questions that you would really hope that they will have picked up on. So the next video that we show them is the power of circuits. It's a short 4-minute, just under 5-minute video. And it's a really great video to talk about simple circuits and how they are made. Ask the students then, what did you learn from that video? So again, print out for your activity, print out the simple paper circuit template below. This is available in your academy. And if you turn to the next page, I have other great resources there for more paper circuit template inspiration. I would advise you to try this before you do it with your students. When I was doing this training last year live with 15 teachers, or 10 to 15 teachers, this really tripped them up, and I was quite surprised that this really tripped them up. It took a lot of struggling to really get this done in the correct way. So it caused a lot of laughs as well, and it really goes to the point of making sure you prepare for these classes so that you know how to troubleshoot and help the students. It really is simple when you know how. And one of the tips is that you also need a simple sellotape to stick the button cell battery down. It has to make contact with the copper wire, but it needs to be stuck to the paper also. And also you need tape, to just plain tape, not the copper tape, to stick the legs of the battery down, the legs of the light down to the copper tape also. You will see in the diagram here, the simple circuit diagram, that the light bulb has one leg longer than the other. And when you open your bulbs, you will see that this is also true. For these bulbs, let me open these. So I hope you can see this on the video. one leg of the light bulb is just longer than the other leg. This light bulb will only light if the long side of the light bulb is on the positive side of the battery and the other leg on the negative side of the battery. So that's one place that we can be tripped up. These are easily bendable, so when you're placing them in a circuit, you can bend the legs so that they lay flat in the circuit, but they need to be taped down to that copper wire. So start off with one battery and one light in a simple circuit, and then explore the other resources and templates that I've connected to there in the binder as well, and have fun with it. It really can be quite confusing until you get it right. I actually tried it with my children the other day, and they were really struggling because I just left them to try and work it out on their own. There's a lot of copper tape under and over the appliances, and it just didn't work. So just do try it on your own before you bring it into the students. Before we delve any further into circuit cubes, I would like to share with you an introductory video about circuit cubes. It's only a minute long. Awesome. So that short introductory video to circuit cubes is fun and should really whet the appetite of the students as to what they can build using circuit cubes when they become more familiar with the components and what they can do. So I didn't want to reinvent the wheel for the purposes of this academy, so I referred a lot to the lesson plan book, and we will investigate some of the vocabulary that we're using in further sessions with the students. I will show you the lesson plan book in a moment and show you how involved it is. There was no point in trying to reinvent the wheel. So the blue cube is the battery cube. This produces the power to animate projects. It's got a simple on-off switch, and you charge it using the included USB charger. Then we have the yellow cube, which is the LED light cube. These cubes are magnetic and stick together very easily. The next page we have the motor cube. This is the pink cube, and it has attachments to attach to the motor, and the motor can be driven by the power of the battery. To make the electric circuit, there are included little wires like this that clip on to the metal parts of the circuit cubes, like so. So these are easily clipped on. When I saw this product, I was blown away with how easy these were to clip on over crocodile clips for the students. Less frustrating for our younger students, most definitely. And they're quite durable as well. Then we talk about electrons, polarity, and also I've got a please remember highlighted here. Circuit cube batteries should never be combined because doing so will damage them or other circuit cubes. So only use one battery at a time. They are quite powerful, stay charged for quite a while. So the circuit cubes lesson plan goes into more detail and is very well written. So as I said, I didn't want to reinvent the wheel. I'm going to show you the circuit plan, the lesson plan book. I did have it here somewhere. Let me see if I can find where I had it open. Maybe it's down here. There it is. Sorry. Okay. So I will include this in your USB as well. It's freely available on their website as their lesson plans. As I said, this Circuit Cubes was really well thought out. So it has 10 separate lessons actually for the lesson plan book. And it tells you the duration, the background, the goals and the objectives of each of the lesson plans. And also things to engage the students, things to notice and wonder. The question, what would happen if? I've put that in my PowerPoint presentation. I think that's great. What would happen if? Change it up. Cross the wires. Take a wire off. What would happen? Then they also have a math connection as well and a reflection step. So I couldn't have bettered this. This was really, really well written. So I included a lot of these ideas in this academy and gave full credit. I actually spoke to the person at Tanaka Labs that developed this, and he was fully encouraging to try and get his product out to as many schools as possible and was really excited to hear about this academy being produced for our schools. So lesson 2 goes through the same process, lesson 3, lesson 4. I have taken these and maybe combined them somewhat differently, but for the most part, the lesson plans are in the Circuit Cubes lesson plan book. So going back to the academy, we talk about the circuit cubes, the students get to investigate the circuit cubes, and then we have a discussion at the end. So at this stage, it's important to introduce the concept of materials which conduct electricity and those that don't. So I've included a less than a 5-minute video here. What are conductors and insulators? If you click on that link, it will take you to the video, and we can talk about then what is an insulator, why are the wires covered in plastic, and what is a conductor? And that will bring us on to session 4 and 5. So for sessions 4 and 5, the objectives for the students are to build a flashlight, make a hand crank flashlight, and learn about light energy. So open your PowerPoint presentation again and divide your class into teams of 2 or 3 depending on the class size. They will keep these teams for the duration of the academy. Have a Circuit Cubes lesson plan book available and print the student observation and reflection sheet, or use the questions to pose questions to the class which they can answer orally. So activity 1, each group needs a 4x8 plate, which is included in the kit, a 1x4 stud beam, which I have here, also included in the kit. These are genuine Lego parts. Some pegs, which are in the bag, 2 of the connection wires, and a telescope tube, which is also connected. Really nice and durable telescope tube, which is also included in the kit. This book is a shorter version of the Circuit Cubes lesson plan book and comes with the STEM starter kit. And it has lovely explanations of each of the cubes. All the items that come with the STEM starter kit also that are available in your kits, even when you buy the class pack, all these items are available. So project 2 is the make a flashlight, and it goes through step by step in the steps that you need to put the cubes together to make your flashlight in your telescope tube. Project 3 we're also going to do during session 4 and 5, and it's to make a hand crank flashlight, which you can see here in the lesson plan book. There are also pictures in your lesson plan book for these as well in the order to put them in. And you hand crank the motor to produce energy for the light using a wheel on the motor. Activity 3 for this session, session 4 and 5, is to make a gobo flashlight. A gobo flashlight is placing something in front of the beam of light to produce a shadow effect. And it tells you in the book here. So to start this activity, I've linked to a light video by the Dr. Binox show. He does really, really great videos to help with the understanding of this activity and how shadows are formed. So inside this telescopic tube, there is actually a little clear, you can't see it, it's hard to see on the video, a clear disc. And on this disc you can put stickers, use erasable markers, felt, cardstock, tissue paper, anything in there. And the vocabulary I want the students to learn from this are transparent, translucent, opaque. Gobo means goes before optics. So this thing goes in front of the beam of light to produce a shadow or to make a design. And then projection as well, presentation of an image on a surface. So you'll be able to see the projection of your pattern or your shadow on a surface. So this experiment is really to have the students explore items which block light or allow light to pass through it. And that's a huge part in the middle elementary school years, to learn about light energy and what blocks light energy. So I thought this fits in really, really well with that. So they're going to make 3 different types of flashlights over the 2 sessions and really give some time to explore and develop their play with circuit cubes. For session 6, we're going to learn a little bit more about robotics and why they're important to us. So before we make a simple robot using circuit cubes, it's important to understand a little about robots and how we use them in our lives. So I've connected to 2 videos here: Brief History of Robotics, which is a 10-minute video, and Real Life Robots, which is a 4-minute video. If you are teaching students and using Mystery Science, there is a great human system video which highlights robotics and how they're similar and different to the human body in Mystery Science also. So that this can really connect with your curriculum as well in that way. So open the discussion with the students using questions such as, can you name any robots that you use every day? And what can robots do for us? They may be aware of some simple robots that you use every day and may not be aware that other things are robots also. Why are robots important and what are the advantages of robots? This should really lead to some really good questions and answers from the students. Then show the students this video, the Robot Challenge Crash Course Kids. In our school, we've focused a lot on students learning to code robots in technology lessons with Hour of Code and things like that. But it's equally as important to learn how to build a robot before you can code it to do a task for you. So in the Robot Challenge video, a lady called Sabrina has a problem that needs solving, and through the power of an engineering design process, Sabrina solves her problem. So while you're doing this in the classroom, project the following slide on the board. It's the children's engineering design process poster that we use here at the Diocese of Buffalo. And I would like you to pass out blank booklets, sheets of paper folded over, stapled together, to make a little paper booklet for the students to use over a few weeks. I normally take 3 or 4 sheets of blank computer paper, fold them in half, put 2 staples along the edge, and invite the students to write their names, a team name, and write the students' names on the front of the booklet. And then ask them either, can you think of a problem that could be solved by building a robot? Or give them a simple classroom problem that needs solving, such as a robot to pick up pencils. We know we always find those on the floor, or crayons, and nobody's ever dropped them, or a robot to close drawers that are left open, something simple that you could think of that needs solving. So initially, we have to go through the first steps of the engineering design process, and this is a really important process to teach to our students. We need to ask the question, what is the problem? And then we need to brainstorm solutions. Brainstorming is very important, and no idea should be thrown out at this stage. So project the brainstorming slide onto the board and tell the students that they need to put judgment on hold and that freewheeling is welcome. The more ideas, the better for something like this, and use piggybacking on ideas. It's not copying somebody, and they need to realize that it's good to piggyback on ideas when you're brainstorming something for a project. So session 6's whole activity is really about learning to cooperate and collaborate with your team members when they propose an idea. And this will be important in future weeks. At the end of the session, collect those little booklets that the students have made and keep them for future weeks when they will be challenged to engineer robots using the circuit cubes and Lego. Tell the students over the next few weeks we'll be learning to make simple robots using circuit cubes and Lego. The engineering design process will be very important when we get to that stage that we use the circuit cubes to build our own robot. So really emphasize the importance of this brainstorming and drawing and freewheeling ideas in the engineering design process. And I've purposely done a session where there's no hands-on because I feel this is really, really important to emphasize to the students this is a very, very important part of the engineering design process. So for session 7, the students create a robot is one of the objectives, and students will observe the patterns made by the robot. So in preparation, you can open the PowerPoint presentation and pass out circuit cubes to the groups. The introduction and the discussion part of this is to show the video of cleaning patterns for a robot mop. And there's a picture on the slideshow that you should show to the students the many, many different moving parts that need to work together for the robot mop to perform its task and make our life easier. Point out the various different parts on the labeled slide. So point out to the students that the engineers have worked collaboratively and creatively to manufacture this robot, and ask the following questions. Do you think this invention seemed crazy when it was suggested? Does anybody have one of these in their homes? Ask them, is it perfect or does it sometimes get stuck? There's horror stories out there of what these robots sometimes do if something happens in your house, like your pet has an accident and the robot turns on and smears the accident all over the kitchen floor, various things like that. So it's not a perfect robot. It's very, very good. I wish I had one in my home, but it's not perfect. And ask them, do you think making this robot was fun? Why or why not? Engineers will have spent many hours to build many prototypes of this robot to get it to work effectively and efficiently. Depending on how the parts are attached to each other really affects how the robot works. So point that out to the students that they had to do a lot of tweaking and perfecting until they could get a finished product. And it's still always in collaboration with other engineers to make it even better than the previous model. So for today's activity, students are going to make a Scribblebot, and we saw examples of the Scribblebot on the short 1-minute Circuit Cubes introduction video. We would like the students to observe the patterns that the Scribblebot makes and then modify the Scribblebot to make other patterns. And yes, these markers are included with the Circuit Cubes kit and a little clip to attach to the robot. You can see there in the bag a little clip to attach to the robot, which then attaches to the pens in the kit. It would be really, really good to have large pieces of paper to do this on. It'd be great on the floor, so that the students can really, really decorate a big piece of paper with their Scribblebots and not be worried about the Scribblebots going over the edge of the paper. Once the Scribblebots have been assembled and the students have had time to explore them, ask them about, is there a difference in the designs the pen makes when you change the location of the pen's attachment point on the bot? Can you predict the direction of the bot? And can you predict the pattern the pen will make? These are all great questions to really get them thinking about what their Scribblebot is doing and how it's moving. If you look further for more exploration on this, you can look in the Circuit Cubes lesson plan book. And if you have time at the end of the session, make a 2-marker Scribblebot and investigate the patterns that that type of Scribblebot makes. That's lesson 7 in the Circuit Cubes lesson plan book. I'm just going to show you. So this is the first Scribblebot, and it shows you all the items you need there and what it looks like. And a 2-marker Scribblebot and the items you need also. In the big Circuit Cubes lesson plan book, it's lesson 6 and lesson 7. Oh, lesson 7, sorry, is make a 6-marker Scribblebot. So all 6 markers can be attached to a Scribblebot. And lesson 7 in the Circuit Cubes lesson plan book tells you how. So the objectives for session 8 are that students create a chassis for a robot, and students will observe the benefit of simple machines in robots. As an introduction, we learn that more complex robots are made from many different components. The video attached below shows the robot guts of a dash and dot robot, which is a popular classroom robot used for coding that the students may be familiar with. It's only a 3-minute and 40-second video. It's quite short, but there's lots of information in this video about the different components that really go into making Dash and Dot the fun classroom robot it is. So point out to the students that you can see from this video that there are many circuits within a complex robot. The green circuit boards. A different circuit is required for each of the different actions that these robots can perform. And that the main part of the Dash and Dot robot is the motor with the wheels attached, or the chassis, like we have a motor in our circuit cubes. The wheels move due to the action of a simple machine, which is the gears, which we also have in our circuit cubes class kit, which helps the motor turn wheels. So that's the introduction and discussion to really get the students thinking about the different components that they might need to build a chassis for their robot. The activity for this is that during the building of the chassis for a robot, the students will learn how the gears interact and how they affect the movement of the car. This background is taken from the lesson plan book. When you think of simple machines, you may think of a screw, lever, wedge, pulley, or ramp. The simple machines that make our life easier also include gears, because gears harness force. The simple machine is basically a wheel with teeth, sometimes known as a cog. To create a gear, you must have 2 teeth that fit into another toothed wheel. If you turn a larger gear that's connected to a smaller gear, you will cause the small one to spin very quickly. Very little effort is needed to turn the gear. In contrast, by spinning the smaller gear, the larger one spins much slower. However, the force is stronger. I've included a link to a video called Simple Machines Gears. It was put on the internet for grade 4. It's grade 4 Simple Machines website. So if you click on that link, it brings you to a website that you can scroll down to the video, and you can stop the video at about 2 minutes and 30 seconds, as this covers all the things that we need to know about gears and speed for right now. If you want to watch the whole video, it's nearly 11 minutes long. There is some good information in it about gears and force and about gears and bicycles. That could be saved for another day. or done, at the same time. But really, after 2 minutes and 30 seconds, it's covered all that you need to know about the gears working together and reducing force. So the vocabulary for this session are chassis, which is the base frame of a motor vehicle, which you could use this piece of Lego for that's included in the kit, a cog, and a gear. The cog is in this little bag in here, and a gear, a simple machine, and speed. So the Circuit Cubes lesson plan book goes into a lot more detail again, but this is a really great time for the children to get into that extra Lego that you may have gathered over the past few weeks and really build a nice platform for their car to move. If there is more time, at the end of this session, students can try lesson 9 in the lesson plan book, which is called Hack Your Ride, which delves a bit further into making your motor vehicle chassis and making it an even better car. So for session 9 and 10, the objectives of this are for the students to explore and create. And that's why I really encourage you to really get lots of Lego for the students to make really fun things. You can go to the Circuit Cubes YouTube channel and explore some really fun videos that have been submitted there. With Circuit Cubes, Lego, and general classroom supplies, many wild and crazy creations can be made. Let your imagination run wild. Check out the remaining lesson plans in the Circuit Cubes lesson plan book for more robot builds with plans. And once the students have mastered those robots in the lesson plan book, they should be able to apply what they have learned to construct new creations. At this time, to keep on track, it may be helpful to suggest a specific build that you would like to see each group build. Some groups may need an extra light cube, whereas other groups may need to use an extra motor cube. Direct the students to ask the other groups if they can borrow what they need. So some examples: build a Lego house with lights. That would be really fun to see. A vehicle that can carry a certain weight. That would be a great competition to have if you can build a vehicle that can carry 20 pennies or something like that, some cubes that you have in your classroom. A vehicle that can carry a certain weight, a certain distance. Get some maths involved there and graph how they carry these weights a certain distance. Design a cover for the chassis to make it look like a boat or a dinosaur. They can use cardboard for this. They can use construction paper, anything like that. In lesson 10 in the book, you can build a tower and maybe add a load. There's lots of different ideas out there of further things that you can do with Circuit Cubes. So please, please really let the students explore. As I said previously, there is a PowerPoint presentation to accompany this academy. And I'm going to go through it briefly now so that you can see all the resources that are available on the PowerPoint presentation to guide you through the class and help you stay on task. So first off, title page, Circuit Cubes and Robotics. The objectives for session 1 are projected on the board so that the students know what we're going to learn about in session 1. The discussion questions are also projected on the board, and we ask these questions before we show them the video, and again after we show them the video about the history of electricity. So here are the links to the videos that I have chosen from the internet to highlight the timeline of the discovery of electricity. The 3 bottom ones are the ones that are in your binder, and this top one, the history of electricity behind the news, is the new video I found while I was making this training video. So I posted on here pictures of various things that use energy and use electricity, so that the students would be triggered to remember even more things that may use electricity. Just fun graphics. that the students can relate to. And again, these are the discussion questions to ask after the videos, same ones we asked before. I always try to put the PowerPoint slides in twice if we need to use them twice, so that it helps you stay on task in the classroom. So the session 1 activity is creating static electricity. The instructions are here on the PowerPoint presentation for all the students to see. And then we go on to session 2, learn about circuits and explore paper circuits. This is the simple circuit that you can project on the smartboard in your classroom, and to talk about the different things that make up a simple circuit: the battery, the wires, and the load. Then this is the link to the Power of Circuits video. I always put the time on the video so you know if you have time to show that video in class or not, or you need to leave it for another time. Session 2 activity, print out the simple paper circuit template, hand out the supplies, and emphasize about the LED bulb having one leg longer than the other, and it must be on the positive side of the circuit. These are the supplies that the students need: the simple circuit, the copper tape, the lithium cell batteries, and the LED diode. This is a link to a tutorial for a paper circuit that you might find helpful to show in class and show the students how to construct these paper circuits. These are some other examples of paper circuits which you can use to show the students when you ask them to think about what they might like to make in the future, if they can make other paper circuits. A Mother's Day card, this is a birthday card, a Christmas card, fun things that you can use to make with paper circuits. Session 3 objectives are to explore simple circuits using circuit cubes and introduction of the components of circuit cubes. Here you can project these pictures on the board as the students look at the various cubes. Session 3 is the activity to explore the simple circuits using circuit cubes. The videos for session 3, and then some examples of conductors and insulators. I would encourage you to ask the students about these items before we show them to them, so that they can really think about what is a conductor and what is an insulator. Session 4 and 5 are to build the different types of flashlights. As you can see in this academy, I've left a lot of time for exploration and discovery. It really is for discovery of circuitry and the different things that the students can make. Allow them to explore, make sure you've got plenty of Lego on hand to aid in that exploration. Session 4 video is the Dr. Binox show video, and this is a slide to talk about the vocabulary words that we're learning about in this session: transparent, translucent, and opaque, and the different things the students can explore with the light, the flashlights that they've built. Session 6 objectives are to learn about robotics and why are robots important to us. These are the videos linked here: brief history of robotics and real-life robots. And the questions, the discussion questions: can you name any robots? What can robots do for us? Are they important? And what are the advantages of robots? Here is the slide for the children's engineering design process from the Diocese of Buffalo. And it goes through the process of what is the problem. We need to then brainstorm the solutions, create the solution that you think is best, test your solution, and evaluate your solution. All very important processes. In this session, we emphasize the first 2 items in the engineering design process. What is the problem, the ask, and the brainstorm solutions, the imagine. The other 3 parts of the engineering design process can be utilized in sessions 9 and 10, where they plan and create, test and improve items that they build from circuit cubes and Legos. So for session 6, pass out the blank booklets made from sheets of computer paper, have the students come up with a team name and write their team name on the booklet and the team members' individual names. Then can they either think of a problem that could be solved by building a robot or a simple classroom problem that needs solving? Again, here's the brainstorming slide to put up on the board so that the students can really come to terms with brainstorming and what it means. Section 7 objectives. The students will create a robot in session 7 and will observe the patterns made by the robot. Session 7 video is the Roomba mop video, linked here, to see the patterns the Roomba mop makes. And then this is the components of the robot mop, and the different intricacies of everything that's involved in having that robot work. So this is the material slide for session 7 that they need to find in their Circuit Cubes classroom kit. And then the questions posed once they've made their scribble bots and have them writing and drawing on the paper. Session 8 objectives, making a chassis for a robot. And here's the guts of the Dash and Dot robots video that you need to show them prior to them building their chassis. Some of the vocabulary we're talking about in session 8. And then the session 8 video for simple machines gears, which is a very important part of any robot we make. They've already used gears and cogs when they were making the flashlights, the hand crank flashlights possibly, and for getting the wheels to move on their scribble bot. So they now need to learn about what the gears mean. Session 9 and 10, I invite you to look at the Circuit Cubes YouTube channel, get that booklet out from session 6 that the students started for brainstorming a robot that they could make, and have them explore further circuit cubes and Legos and how they can connect them to make simple robots in the classroom. Again, here's the engineering design process, picture, and the brainstorming picture so you can use them again. Thank you for listening to my training video. If you have any questions and concerns, please contact me at spowelzik@buffalodiocese.org, and thank you.